For decades, robots have been these incredibly powerful but honestly kind of dumb machines, right? They were just locked into repeating the exact same task over and over and over. But that is all changing. We are right in the middle of a revolution where machine learning is giving robots something they have never, ever had before: a mind that can actually learn.
You've definitely seen the videos. On one side, you've got a robot arm just clumsily fumbling around, dropping parts, a total failure. And then, in the very next clip, you see a robot performing with almost superhuman precision. Maybe it's threading a needle or something equally impossible. So what on earth happens in between? What's the secret sauce that takes a robot from chaotic failure to flawless execution?
Well, the answer isn't just better code or, faster processor. It is a complete paradigm shift. It's so profound that it makes that old school line-by-line programming look like it's from the Stone Age. We're moving from a world where we tell a robot exactly what to do to a brand new world where a robot learns what to do on its own. And that's exactly what we're going to break down right here. We're going to look at the 3 fundamental ways that robots learn, and then we'll see how those techniques build the essential pillars, perception and action, that create a truly intelligent machine. So, how in the world does a machine actually learn? It really just boils down to 3 core techniques. Think of these as the foundational toolkit for building a robotic brain. First up, we've got supervised learning. This is basically like teaching a robot with flashcards. You show it thousands, maybe millions, of images that you've already labeled, like this is a screw, this is a bolt, hey, this one's a defect. And eventually, the model just gets it. It learns to recognize them all by itself. This is the absolute powerhouse behind object recognition. Next, there's unsupervised learning. Okay, so imagine dropping a robot into a totally messy, chaotic warehouse for the very first time with 0 instructions. Using this method, the robot starts analyzing everything it sees and just finds patterns. It starts grouping all the round objects over here, all the square boxes over there. It's essentially creating its own map and its own sense of order out of pure chaos. And finally, my personal favorite, reinforcement learning. Now, this one is all about good old-fashioned trial and error. The robot tries to do something, and if it gets closer to its goal, like successfully taking a step forward, it gets a little digital reward. If it messes up, it gets a penalty. You do this millions of times, and it learns the absolute best strategy. Pretty much the same way you train a puppy with treats. So to kind of wrap this part up, each method is the right tool for a specific job. You've got supervised learning, which is perfect for object recognition since it learns from labeled data. Then unsupervised learning, great for navigating new places because it finds patterns on its own. And reinforcement learning, which is the key to mastering really complex actions like motion control through trial and error. Okay, so we have these powerful learning techniques, but how do they actually come together to build a robotic mind? Well, it all starts with the senses. Before a robot can do anything, it has to be able to perceive and understand the world around it. This is the first and, honestly, the most fundamental pillar: perception. And perception is so much more than just having a camera. It's all about interpretation. Machine learning lets a robot do real object recognition, like spotting one specific part on a fast-moving conveyor belt. It enables scene understanding, so it instinctively knows the difference between a floor it can drive on and a wall it has to avoid. And it powers this amazing thing called SLAM, which is where a robot builds a map of a new space while at the same time figuring out its own location inside that map. This slide just sums up the difference perfectly. The old way, you had to manually program the exact dimensions of an object. If a slightly different version came down the line, the whole system would break. The new way, the machine learning way, you train the robot on thousands of examples. So it doesn't just memorize dimensions, it learns the concept of the object, which makes it incredibly flexible and way more robust. Okay, so our robot can now see and understand its environment. What's the next logical step? Well, it's turning that understanding into purposeful action. This is the magic moment where perception connects directly to planning and doing things, where seeing becomes doing. And here's basically how that flow works. First, the robot uses its learned perception to see and map its surroundings. Step 1. Then, using reinforcement learning, it can plan the most efficient path to get to what it needs, dodging obstacles on the fly. And finally, when it gets there, it uses its ML models to figure out the best way to actually grab and handle an object, even if it's one it has never seen before in its life.
And let's be clear, this isn't just some theory from a research lab. These are the exact techniques that are fueling the explosive growth of the $100 billion global robotics market. This stuff is happening right now, today, in warehouses, factories, and even hospitals all over the world. So, if these are the building blocks, what's the end game? What's the ultimate goal here? We are now entering what is easily the most exciting frontier in robotics, the creation of a single, highly adaptable robot that isn't just a specialist, but a generalist. I mean, the vision here is truly mind-blowing. One single robotic platform that can understand and carry out thousands of different tasks, all based on simple, spoken commands from a person. No reprogramming, no retooling, it just understands what you want and does it. This is the holy grail of robotics. Think about a simple command like this one. For you or me, it's second nature. For a robot, though, this is an incredibly complex problem. It has to understand language, plan a sequence of many steps, navigate a complex space, recognize specific objects, and then physically interact with them correctly. This is where everything we've been talking about comes together in this beautiful symphony of learned behaviors. And the magic that makes this possible is a new class of AI called Vision Language Action Models, or VLAs for short. So first, the robot sees the world and hears the command. Then a massive foundation model, and you can think of this as the robot's reasoning brain. It's powered by the same kind of AI as ChatGPT. It thinks about your request and breaks it down into a logical sequence of smaller steps. And finally, it translates those steps into the precise motor commands needed to actually get the job done. So here's the bottom line. This isn't science fiction anymore. We have moved beyond rigid, pre-programmed automation. The new architecture for everything is one of learning, of perception, and of generalization. This is what's going to define the entire next generation of robotics. And all of this leaves us with one huge, final question to think about. Once these building blocks are perfected and put together, what becomes possible in a world where any robot anywhere has the potential to learn how to do almost anything?